Hello everyone. So the topic for my experiential learning is FE analysis of camshaft using composite material. So let us begin with the introduction. What is a camshaft? A camshaft is a rotating component in an internal combustion engine that converts rotary motion into linear motion. It is responsible for controlling the opening and closing of the engine's intake and exhaust valves. So how does it work? There's a eccentric cam. The camshaft has an eccentric cam profile, which means it has a raised portion, which is known as the lobe, and a lower portion. And it has a follower. A follower rides on the cam profile. Then there is the valve train. The follower is connected to the valve train, which includes the valve spring, rocker arm, and valve movement. As the camshaft rotates, the follower moves up and down along the cam profile. So the motion is transmitted through the valve train, causing the valve to open and close. So, how does material affect camshaft performance? The material used for camshaft significantly impacts its performance and durability. Different materials offer varying advantages and disadvantages, influencing factors such as strength, wear resistance, weight, and cost. These are the key material properties for camshaft. Strength. The camshaft must be able to withstand the loads imposed by the valve springs and other components without deforming or breaking. Then weight also plays a huge role in improving the efficiency of the camshaft. A lighter camshaft can reduce the engine weight, improving fuel efficiency and performance. What are the common camshaft materials? The common camshaft materials are cast iron or chilled iron, steel, forged steel, and composite materials. What are the advantages of composite materials? Composite materials are lightweight. They are generally lighter than the materials, reducing engine weight and improving fuel efficiency. They have a high strength to weight ratio. They have fatigue resistance, design flexibility, and corrosion resistance. What are the disadvantages of a composite camshaft? The disadvantages are higher cost. Composites can be more expensive than traditional metals, especially for large scale production. And then there is the manufacturing complexity. Manufacturing composite camshafts requires specialized equipment and techniques which can increase production cost and lead times. Then there is brittleness. Composites can be are more brittle than metals, making them susceptible to fracture under certain loading conditions. So let us begin with the FE analysis of our composite camshaft. So first thing you need to do is you have to import geometry from a SolidWorks, convert it into a HTEP file, then add it in the geometry. So as we're doing a composite camshaft, we have to add the composite materials in our engineering data. So we have already added the materials. We have added aluminum silicon carbide, carbon fiber, iron. So if you need to add a new material, you have to click here and you have to add the values of Young's modulus, Poisson's ratio, and density. And if you're doing transient analysis, you have to add the SN curve to get your fatigue life and the life cycle. So let us begin with our project. So in our first analysis, we have chosen cast iron. So the reason cast iron is chosen as material for using camshaft is that it has high wear resistance, it has a ease of machining, and it is durable, and it is also cost effective. The wear resistance is due to its hardened surface. Cast iron, particularly chilled cast iron, can be produced with a very hard surface layer. This hardness provides excellent resistance to wear, which is an essential component that experiences essential for a component that experiences constant contact and friction. So we'll begin our analysis with starting with cast iron or chilled iron, which is usually used for camshaft. So we have done a general mesh. So in our static structural analysis, we have fixed this end of our camshaft, and we have given it a moment of in the Z component of 8,000 Newton per millimeter, and we have given it over these faces, and the rotation is in the anti-clockwise direction. So as we can see, The total deformation is 0.011379 millimeter, and this is how the camshaft would react under that deformation under our given moment loads. The equivalent stress for this material is 8.0116. So let us go to our modal analysis. In this, we can see that the natural frequency for the cast iron or chilled iron is 100 hertz. And this is the deformation that would take place during that frequency. So let us analyze for the composite material which we are using as aluminum silicon carbide. So you can change materials by going to geometry and in the path section, and you'll get a material assignment, and you can change your material over here. So let us solve this. We can see that the deformation for the aluminum silicon carbide is 0.00699938, which is lesser than the deformation that took place during our analysis for cast iron or chilled iron. And this is how the deformation would look like. And the equivalent stress is almost similar, but we'll find a major difference in the modal analysis. So we can see that the natural frequency for the aluminum silicon carbide is 201.13, which is more than the natural frequency of cast iron or chilled iron. This is a favorable characteristics as resonance won't take place fastly, and this is a good characteristics as resonance is a bad thing when manufacturing a camshaft. So the basic difference between chilled cast iron and aluminum silicon carbide, as we have seen, the aluminum silicon carbide is lighter in weight and has an excellent strength and stiffness. It has excellent thermal conductivity. It has better wear resistance, corrosion resistance. But the only defect in this material is that the cost is higher and the manufacturing is more complex. As we go further in time, the cost might reduce and the manufacturing will be easier for mass production, and we might see the use of aluminum silicon carbide used in camshafts. So this was the base for our FEA analysis for composite materials in camshaft. Thank you.